Hi, I'm Tom Veazey. I'm Director of Research and Development at Prelert. Today I'm going to talk about what is anomaly detection, what sort of data sets we're trying to do anomaly detection on, and at a very high level, the approach that we take. So, what is an anomaly? A common definition is a pattern that's sufficiently different from normal behaviour that is likely to be generated by some completely different process. Anomalies can be points, so a single value that's way away from normal, or they can be context dependent. So a temperature of -40 degrees Celsius would be very low in London, but typical in winter time in Siberia or Alaska. Anomaly detection should also try and give as much information as possible that allows a user or an analyst to identify what the problem is. The data sets that we work with are enormous, so we have to be able to scale to handling tens or hundreds of thousands of different metrics, or gigabytes, even terabytes of data. We've chosen to make our algorithms work online. That means that they can scale to almost arbitrarily large volumes of data, provided they can keep up with the data rate, but it makes implementing them harder. The models that we use have memory, or at least they're able to forget old learned behaviour. They use sophisticated statistical techniques to try and eliminate as many possible false alarms. The raw input is semi-structured data. We turn that data into a set of features that we can provide to a flexible statistical engine. So those features might be the count of values in an interval of time, or the distinct count of values in an interval of time, or the maximum value in a time interval. Once we've got this normalized data set, we have to do various things to it in order to model it accurately. Time series data has correlations in it, which means that values that occur close in time are typically related, or possibly close modulo the period. And we remove those slowly changing components of the data in a process called detrending. Once the data's been cleaned up in this way, we're able to look at other features. For example, we look at clusters in the data. We take an approach that's based on an algorithm called Birch, and it describes or creates a summary of the data that we're able to then run clustering on. We use information theoretic approaches to decide when data should be split, which means that it works in an unsupervised fashion. We finally want to model the characteristics of that data with a set of statistical distributions. We use a Bayesian framework that allows us to fit both model parameters and also select the best model from amongst a family of different models. Creating the model is only part of the story. You need to be able to say what's anomalous given that model. Users want consumable or easily consumable information. They want, ideally, an alert about when their system is misbehaving or when somebody is doing something malicious. We use historical scores to construct quantiles that allow us to say what's normal, or at least what's a normal value for the score, and what's an exceptional value for the score, what really could be a system problem. So, in conclusion, today I've talked a little bit about what is anomaly detection, what are the challenges for anomaly detection in a modern setting, so with modern data sets. And what we've done at Prelert is to package that all up so you can get the advantage of some great research without having to be a data scientist yourself. For more information, go to prelert.com. Thanks for listening.